Hello and welcome to today's webinar. Tolly Group validates Citrix ADC performance advantage for better application experience. My name is Darlene Jaramillo and I will be your host for today's presentation. Our featured speakers for today are Kevin Tolly, founder at the Tolly Group, and Dr. Jason Poole, product marketing at Citrix. Before we get started, let me cover a couple of housekeeping details. We will have a dedicated question and answer session at the end of today's presentation and invite you to submit your questions at any time during the presentation using the Ask a Question window in the webinar interface. Also, this event is being recorded and a link to the on-demand version will be sent to everyone in a follow-up email. With that, I will now hand it over to Jason to start the presentation. Welcome and thank you for joining us.
Thank you, Darlene. Yes, this is Jason Poole. I am in the product marketing team at Citrix, and as Darlene said, I'm joined by Kevin Tolly today, who's a founder member of the Tolly Group, as we talk a little bit about the performance testing of ADCs. And Kevin, why don't you tell us a little bit about the Tolly Group and what you guys do there?
Sure. Hi, Jason. Hi, everybody. Tolly Group's been around for about 30 years now, and we are a IT consultancy specializing in providing third-party validations for IT claims, whether they're speeds and feeds, features and functions, whatever capabilities, to provide that type of validation to help users essentially make product decisions based on fact, not fiction. Thanks for having me here today.
Thanks. Fact, not fiction. I love it. Okay, just before we get started and I turn this back, I just want to say a couple of words on why Citrix commissioned these tests. Now, we know, and we were working with applications for years, that we know that applications, they are the cornerstones of business operation today. They become a critical asset upon which businesses are built. Nothing happens that's not underpinned by an application of some sort. And as such, application performance is crucial to productivity and customer retention. App delivery, therefore, is paramount. And with apps shifting to the cloud, there's been a rapid growth in the deployment of ADCs. And in particular, we're seeing a lot more cloud-based ADCs. And alongside this, we're seeing a shift in application architectures away from that monolithic structure to microservices-based. So we wanted to find out how well the Citrix offering performed compared with others, especially with respect to latency and its impact on application performance and user experience. In particular, we wanted to examine the performance of the Citrix ADC VPX, the cloud virtual machine image, in hybrid multi-cloud environments, and the performance of the CPX version of the Citrix ADC, the container-based version, and how that would perform in cloud-native type environments. So that's why we commissioned the Tolly Group to test this out against others in this area.
Okay, and let me talk a little bit about the test goal. So you can see here, what we're looking at, as Jason had said, we're looking at latency, right? So what's latency? Delay. And as we look at applications, whether they are more the traditional going through an ADC instance or microservices based that we'll look at, you're talking about transiting this this device or this virtual device. And delay is the most important thing. We have transactions where there's lots and lots of objects, large and small, being moved back and forth. And each and every one of those has to transit, and the latency, the delay on each and every one of those is going to ultimately to impact user performance, whether it's performance that they can see visually because it's an interactive application, or it's microservices where they can't see the interaction, but their time for completion of the application, for example, is going to be affected by it. So we'll be looking at that, and I'll talk about it. Transaction and volume. You'll see that as we go through all of this. So for those of you who might be familiar with switch type of testing, one way of thinking of it is when we look at network switches, we run smallest frames and largest frames, 64 bytes and 1518 bytes. Think of the transaction test as the small frames. There, we're really exercising the kind of the setup teardown mechanism, as we would be exercising the network fabric in a LAN switch. With the volume testing, as you'll see, we're using large object sizes, and here It's not only the transaction, but it's getting the rest of the payload out and across. So it's nice in that it gives you a real good bracket of the two types of, or the extremes rather, of the testing. You'll see TLS 1.3, TLS 1.2, so we're looking at both types of transport layer security, the current type, the newer type. So you'll see that we're going to take a very, very structured approach to these tests, and as Jason had mentioned, we'll look at the so-called standalone ADC, the more traditional ADC, and also adding to that the web application firewall function, and then we'll look at the microservices, cloud-native mesh type approach when we compare the Citrix CPX to the Envoy proxy ADC. Let me move on. Okay, I'm going to spend a little bit more time on the earlier slides than on the later slides, and I think you'll see why. Primarily because we've taken the same structure, the same type of approach in terms of the tests, and gone through that and looked at each of the solutions in the same way. So I'll take a little bit more time, and Jason will join me in highlighting some of the discussion early on, and then we can move through the slides a little bit more quickly as we progress. So here's our overview. Here's our overview. So volume throughput. So this is kind of the core test. This is the test of, let's say, large frames, large object sizes, and we just see how much data we can get through the competing solutions. And we'll have a couple variations on that, but that's the basic idea. HTTPS transactions, here is the transaction. Here is, let's just count the transactions, have a very, very minimal payload to see how efficient the transaction processing mechanism is. And again here, HTTPS, everything is TLS. Undoubtedly, solutions could get faster performance if they just did old HTTP, unencrypted traffic, but that isn't the way it works out there now. So I think as Jason pointed out earlier, and we'll talk about it in a little bit, is we want to make sure that what we're doing here is applicable to what you're going to see in your environment. And then with the traditional ADC, as we noted earlier, there are times when you need a deeper packet inspection to inspect and protect against security threats. So we have the web application firewall tests as well. So you'll see all of those. Jason, we can talk a little bit, join me a little bit here. I had mentioned already the importance of testing HTTPS and not HTTP. Any comments there, or I assume you're in agreement with me on that?
Yeah, it's what we see. No one's really sending non-encrypted packets anymore. It's all about HTTPS. And we looked at what should you measure, 1.2 or 1.3, and some research that we did, it sort of showed that they're equally prevalent at the moment. Of course, in the future, it'll probably be more 1.3 than 1.2.
Right, over time, that's where it's going. So it's good to see both, right? Okay.
And
go ahead.
Go ahead. I was going to say the response sizes, we wanted to make this as real world as we could. And so we did some research, and we found that the average web page is about 2 meg, and the number of objects on it is about 100 or 75. And so it worked out about a 30 kilobyte object size. And then 9 kilobytes for the cloud native test, where you're not sending large graphic files between the microservices. So we figured that was about right for that to make it as real world as possible.
Right, and then latency measurements is also very interesting. Those of you paid close attention here, we have P99. This is the first time we've done that in a Tolly test. P99 is basically the worst latency, right? We've been testing latency for, I hate to say it, but literally decades now, and it's generally average latency, and that's an important or valuable metric. But of course, for quality of end user experience, you want to know what's going to happen when things are at their worst, right? If you're overloaded or stressed, or you don't really want to know about the sunny day, you want to know what's worse. So P99 is a very rigorous approach that says, let me get report the latency essentially of the worst 1% of the users. Jason, any additional comments on that?
No, I think P99. I think it represents exactly what you said. It's if someone's coming in when something's under stress, that's the latency they're going to see. That's the experience they will have, and that's something we wanted to monitor.
Right. So that's good. We have that. So again, do keep in mind if you're looking at other results, other places. Typically, you'll see latency, parentheses average. look for P99 because that, again, will tell you more. It's more rigorous, more stressful, and is an important metric. So the tests that we did, we're doing cloud tests, and we actually ran them on the cloud, and we'll give you some more information on that later, but we ran them on AWS instances, so these were not virtual environments that we set up in a lab anywhere. We ran it on the Amazon cloud. So again, focusing on the real world. With the web application firewall tests, we have, as you can see here, some core inspections, things that you always want to be protected from, SQL injection, cross-site scripting, et cetera, et cetera. So tried to, again, pick out a set of profiles that would be indicative of what a customer might want to have out there. So what do we find? And again, we're going to be talking about two things. We'll be going first through the more traditional ADC, and then we'll be going through taking a similar approach through the microservices. So, and again, everything you're seeing here, every graphic I have, including this one, you'll find in the complete report. So you don't need to be taking copious notes. At the end of the presentation, we'll have links as to where you can find and download free copies of these reports. So, but just to highlight it here, you can see, I'm not going to read every letter of this to you, but you'll see, and this is just a distillation of what's in the upcoming slides, 1/5 the latency under stress, okay? So dramatically lower latency than the competing solution, the F5 solution, in tests of TLS 1.3 and 1.2, okay? In the transaction mode, transaction tests, half the latency. So these are very significant numbers. This isn't a 2% difference. And if you look at number 3 item here, we have an interesting slide. In terms of the overall transaction rate, we had a difference of something like 10%. But, you know, at that kind of load, if you extrapolate that out to 24 hours, it was close to 2 billion more potential transactions in a constant loading situation. Now we'll go through that. And then finally, we'll go through the ADC plus web application firewall test, and you'll see here too. Again, lower latency and all the different variations that we did. We did some that were 100% web application firewall traffic and some with different blends, again, to reflect customers that have different needs and different requirements. Okay, so let's take a look. And Jason, please feel free to jump in as I go along here if you've got any comments or if I've missed anything. So I'm going to spend a couple of minutes on this slide because you'll see all of them are going to have the similar type of look and feel. So left-hand slide, left-hand part of the slide, TLS 1.3, right-hand part of the slide, TLS 1.2. So we ran the same tests. The only difference was the encryption algorithm being used. Now let's look over here. You'll see idle and stressed. Again, we're trying to bracket the results that you might get. So the same way as we do volume and transactions to get large payloads and small payloads, we're doing idle and stressed so you can see what each system does in situations where there's very little traffic and then situations where there's a high rate of traffic. Okay? And then finally, in our little inset box here, we looked at what the CPU utilization was for each of the solutions, Citrix in blue and the F5 in red. So a couple things. What we did here was we looked at trying to get both systems at a very similar level of throughput. And you'll see, you probably can't read the note here, and again, this is all drawn from the report. We had 14 gigabits per second. So we adjusted the traffic flow of the Spire and Avalanche to get about 14 gigs going through each of the systems, and then we used the FortIO utility to measure and give us the P99 latency. So a couple of interesting things here. I mean, the biggest one certainly is if you look at the latency under stress, huge differences here in terms of 0.89 to almost 5. Same thing with TLS 1.2, down at 1, up to 5.47. So pretty significant differences in the latency in these delivery of large objects. What was even more interesting, or at least equally interesting, was that at this load of 14 gigabits per second, when we measured the CPU utilization of the virtual instance of the Citrix ADC, as you can see here, talking 43% or 41%, compared to an 83 to 85% for the competition. So what does that tell us? It tells us not only are we getting good low latency, but it's showing us that we've got a lot of headroom. By the time you get to 83, 85%, there's not a lot of place for you to go before your CPU becomes a bottleneck. With the Citrix solution, we have a long way to go before there's any type of CPU bottleneck. But again, in this case, we were trying to get the load to be approximately 14 gigabits per second going through, so we could get more of an apples-to-apples measurement on that. Jason, any comments on this one or anything I left out?
I have a question on that. So idle and stressed, so you say 14 gig, why not go all the way up? Was there
a couple things. Idle? Yeah, well, the idle is basically a light load of 100 requests per second. So just something to keep it going. There's activity going through. It's not one request per second, but it certainly isn't meant anywhere to stress the ADC. Okay, so you can see what would happen if you have an ADC that basically has no load. It just there's little things coming in. You can see there's still a difference. With the stress, I mean, we could have just said, and we'll see. Actually, we took a little different approach with the proxy in a couple of minutes. We could have just said, yeah, let's just go all the way, pedal to the metal, and go to 100%. What you might see in those cases is you might see as it gets to 100%, the efficiency might go down. So we wanted to try to get to a point where we were in hopefully a sweet spot for both, where we had a good amount of throughput coming through, but making sure that the CPU wasn't a bottleneck, right?
And Kevin, what do you think the impact of this 5 milliseconds per object might be?
Well, it's hard to say exactly because every web page is different, but 5 milliseconds is not trivial, and you can just do the math yourself. If you look and you see you have 100 objects, it's not uncommon for pages to have hundreds of objects. It all adds up. So the difference here is certainly something that could be visible to a user by just them seeing a slower reaction to the delivery, let's say, of a web page. And it's important to remember that this isn't the only latency in this whole transaction, right? There's the latency from wherever your user is sitting, and often these days it's working from home, the latency to their closest POP, the latency across to where the service is. These are all different components, and your response time is never going to be better than all these chunks of latency added up. So it's very important and very beneficial to make sure that a service device like the ADC isn't adding a lot, right? As I think we've had discussions before, Jason, where I've said you want to reduce the drag, right? It's really what it is. It's you have to have an ADC because you need to have the back end to be able to distribute that traffic, but you don't want to put a lot of drag on that traffic. And I think here, when you see the low latency, that's showing you that you're minimizing the drag on that traffic, right?
Right.
Okay, let me move forward here. So transaction test, right? Everything is the same here. If you look at it, you're seeing the same TLS 1.3 on one side, TLS 1.2 on the other. The difference here is these are, for those more familiar with LAN switches, this is the small frames, right? Here, you can see we only have a 1 byte response. What we're trying to do is just get action through the ADC and really see how it can handle the different transactions without putting very much in each transaction. Here you can see we're, again, trying to get a workload that is as equivalent or close to equivalent as possible between the two systems, and here it's 200,000 rather requests per second. So we're doing virtually nothing except establishing the connection across the ADC, delivering the 1 byte response, and then starting it over again, and a load of 200,000 RPS. Again, the test scenario is the same. The Spirent Avalanche, if you're not familiar with it, it's a very sophisticated traffic generation tool. It represents the client and the server, so it's stateful activity as we talk across the ADC and back again. It enables us to tune to the level we want in terms of throughput, and then the FortIO utility allows us to get the latency measurements. So we're actually using two in combination here. So very, very similar results. We have, in both cases, or in all cases, stressed and idle, we have far quicker, far lower latency for the Citrix versus the F5 competing. Here the CPU utilization is roughly the same. Again, this makes sense that it's more CPU intensive because we're not just establishing a connection and shoveling data. We're establishing a connection, doing very little, tearing it down, and starting again. So those numbers, they make sense that they're about the same. Still, the Citrix is a little bit lower, a little bit more CPU efficient. But otherwise, we see a very, very similar pattern to what we saw in the prior test. Jason?
Yeah, so we're using the same AWS instance here, the C5Ns that are designed for networking, right? And the first test we did 14 gigs, and this one we're fixing it at around 200,000 requests per second.
Requests, yeah.
And there's, like you say, it's about a 10% more efficient, and it's what is that, 9 milliseconds quicker under stress, right? Maybe a little more. TLS 1.2. Okay. What does that mean then? What's that going to, why is that less pronounced than say the throughput test?
Well, again, the TLS handshake is something that's very, very well defined. These things have to go a certain way. So there's things that they must do, right? So that makes sense that it's more similar. There's really no focus on delivery efficiency or buffering or other things. It's get in, get the handshake done, get the small payload out, and go. Okay?
Okay.
All right, let me move along. Okay, so then the last of our pure ADC tests, and we'll get to some of the web application firewall variant. Just to take a look, and we had mentioned this a little bit earlier, is if we look at our transaction test, we ran a test 7 minutes, we could run it for 7 hours, 7 days, whatever. Again, with equivalent CPU utilization, trying to help you understand kind of what you get bang for buck in terms of the throughput. You'll see here that just in our particular 7-minute window, there was a pretty significant delta between the Citrix and the F5. And if you just take that and say, well, what does that mean? It's 9 million. Okay. Over the course of a 24-hour period, if you were to take that exact same processing rate and throughput and just ran it for 24 hours, it's actually a delta of 1.85 billion more transactions in a 24-hour period. So that's something. So what does it mean to a customer? Are you likely to have it going at that rate for 24 hours? Probably not. But what it means is that you can have the confidence that you can keep this thing going, and that these little changes or not so little differences between the solutions do make a difference. They do aggregate. They can make a difference over time in terms of what the total delivery will be to your users. Okay. So now we took the existing test. Again, you're seeing a very similar looking test here. Everything is the same, except, here we added the web application firewall component to it. Okay. So security is paramount for everybody. The whole reason we're going to TLS 1.3 is to get better security. Web application firewall offers more security at a different level, right? Deeper into the packet, looking for things that might be threats. We saw earlier SQL injection, cross-site scripting. So going deeper into the packet requires then obviously a deep packet inspection. So that's what takes place with the web application firewall. So here we have, this is all for 1.3. I've got 1.2 on a separate slide. Reason being, here the left side is with 100% WAF traffic, 100% web application firewall. The right side is a different blend. 1/3 of the traffic is web application firewall and 2/3 is ADC. Why? Because a lot of users might want to run some traffic that it has deep inspection and other traffic is just standard ADC. So here too, again, we can see the latency for the Citrix solution is always lower by a couple of milliseconds or more as we look at the environment here in each of the type of deployment scenarios that we put out here. And in our little inset with our CPU utilization, similarly, we have a difference where the larger in the 33% WAF. Why? Because we just have core ADC for 66% of the traffic. But even in the 100% traffic area, we're looking at the CPU utilization, which is demonstrably lower than what we're getting with F5. Jason, any comments here? Or?
Yeah, it's certainly something that we see a lot now. Customers are looking for a consolidated solution for security and application delivery, and often that solution fails or comes up short, shall we say, because of the added latency and the additional compute resource. Now, obviously, doing deep inspection, as you said, Kevin, it does take more processing, but we thought that it's a good idea to actually try to quantify exactly how much that will be so that customers are in a position to make a decision about the types of devices they purchase. And when you've got 25% less CPU utilization, it does lend things into the Citrix camp. And we think that's because of the single pass architecture where the Citrix does the inspections, the load balancing, all of this stuff in one single pass. It takes a packet, breaks it apart, makes its decisions, puts it back together, and sends it on its way. So we think that's why we're starting to see a lot more customers looking at Citrix ADC for consolidated security.
Sure, and it's a simpler service chain, right? I mean, security, for better or for worse, has lots of different components, which, the more kind of the security in depth is great, except if you have 3 or 4 or 5 separate physical or logical layers that you have to go through, that adds a complexity, certainly to management, potentially to cost, and also to performance. So this shows, to my mind, it shows that having the integrated web application firewall is certainly a good thing. It's a simplified service chain, and there's not a significant performance hit. So it's good stuff. Okay, let me move along. So I can go quickly through here. Same tests, only run with 1.2, and we're seeing very, very similar results. So it's almost identical in terms of the results to the prior slide, and certainly the shape of the results is the same as the prior slide. So, here again, your environment may be predominantly 1.2 today, and it may stay that way for a little while, but eventually it's going to be predominantly 1.3, right? That's what the way things are moving. It's not a fork in the road. It's a progression. So it's good to have both sets of results, and it's good to see that in all cases the Citrix solution performs well. Okay, Jason, any final comments before I move on to the service? Okay.
I think it's very similar, actually, isn't it? Yeah.
Yep. So now we're going to take the same approach, only the difference, as we had mentioned earlier, is now we're looking at a service mesh, right? So this is not the traditional ADC where we have a user going through and interacting via the ADC to backend web servers. This is more cloud native, which we're seeing more and more of today, where a microservice or many microservices are accessing other microservices through effectively an ADC in a container. So this is containerized ADC, and here we're looking at the Citrix offering, which is called the ADC CPX, versus the open source Envoy proxy. So you can see here, again, I'll go through this, but the summary, if we look here, we can see, again, significantly superior performance for the Citrix offering versus the open source offering. No disrespect to open source, but we'll go into that in a couple minutes about what some of the trade-offs are there. Yes, it's free, but right, we always have that issue of what do you get for your, for free. You'll see here significant data throughput differences, more than double. Transaction, you'll see more than triple. So these are non-trivial differences that we'll explore in the next couple of slides here. So again, same type of test rather, and same type of stress for this environment. So you can see the 1.3 on the left side of the screen, the 1.2 on the right side of the screen, and obviously your eyes are going to be drawn where mine are drawn to those two big red towers there for the stress tests for 1.3 and 1.2. So you can see here, this is very, very, very significant, from 1 millisecond up to 9 milliseconds, again from a little bit over 1 millisecond up to 8 milliseconds, both in 1.3 and in 1.2. So that's fairly significant latency. And if you remember our discussion earlier today, the microservices are fairly complex. You have a lot of east to west traffic. You might have multiple back and forth types of transactions taking place as you run a cloud native application. And if you're adding 8 milliseconds of delay to every single interaction, that can certainly come back, make your application slower. And if those applications are feeding end users, well, you can see what happens there. So why is this? And I'm going to say a couple of words, and I'll ask Jason to give us the Citrix side. The Envoy is open source. I think LinkedIn is where it came from. Maybe I'm wrong on that. It was developed to do a job. It's out there. It's free. But obviously the main focus is to get the job done. It's a couple years old. It doesn't have any particular focus apparently on optimization. And that compares with kind of the core code from the Citrix side. And Jason, maybe you can give us a little bit of enlightenment there.
Yeah, since it was born, Citrix ADC has been optimizing its core code to do the job better, to make sure that it introduces as little latency and performs as well as it possibly can. So they've had 20 years plus optimizing the Citrix code. So it's no real surprise that it's doing so much better here. But and like you say, I just want to go back one quick second there, Kevin. Like, you said that the effects of latency, they are going to be compounded in microservice environments. So
yes,
every request from the outside is going to go through multiple microservices to create the final object that's going to be returned to a user or to another machine or something like that. So it really is quite a serious problem with latency in microservice environments.
Exactly. And one thing, Jason, it just occurred to me as we've been talking about 20 years, I don't know if we've said the word NetScaler so far in this presentation. All this comes from the world of NetScaler, and maybe some of the listeners who've known Citrix for a long time are sitting there saying, what happened to NetScaler? Can you tell us about that?
It was just a name change. The product is still as great as ever, but they just changed the name.
Right. Okay, that's my point.
So people knew what it was, yeah.
Yep. So anybody who's sitting here and is familiar with NetScaler from way back, this is the core code of NetScaler that's been brought forward and brought forth and into the new environment. Excellent. Thank you. Okay, so here too, we ran the maximum throughput test for volume, and we notice here again pretty significant in terms of double or nearly triple the type of throughput. So here's the test where we're trying to move packets through as quickly as possible. So again, one can imagine a microservices application that is trying, I don't know, maybe it's doing some type of file updates or something that requires more than minimal types of throughput, and moving some catalog information or who knows what it might be. You see here, we're looking at 1.68 gigabits per second to less than 1 gigabit per second. We're looking at 1.8 gigabits for TLS2, again, to less than 1 gigabit per second. So always greater than 2 is pretty significant. So again, you put these things in place, but you want to be sure that you're not just foolishly spending your money, because even though this is free, if you have, let's say, for example, throughput bottlenecks, what do you do? How do you solve that? Well, you have to get a bigger cloud instance to run your container, and a bigger cloud instance costs you more money all the time it's running. So when we look at open source versus optimized commercial software, and this isn't just the case with ADC, but with all the different things we look at, you need to be looking at cost more holistically, right? It's not just what does it cost me to get this thing, but what are the implications of that thing as we go down the road here. And here, having greater efficiency, greater throughput is going to mean that you require less resource that has the ongoing costs. Okay. Again, transaction rate, instead of looking at volume, looking at transaction. Here too, we're seeing very significant differences in terms of here more than double, here close to that, in terms of the latency at the transaction test with the small response size. Again, here too, not really surprising because it's a general purpose open source. We're seeing that the Citrix optimization is helping us out and getting us things a lot faster. And then finally, we ran the same maximum rate test as we did for the standalone ADC, and here we went to 100% CPU because it's a virtualized, it's a container environment. We said let's just go and process as much as you can possibly do, use all of your dedicated CPU resource. And again, here, pretty eye-opening. We see more than triple the throughput on the Citrix ADC side than we do on the open source Envoy side of it. So very, very significant stuff. And again, keep in mind when you're looking at these environments and looking at the solutions, when you look at the cost, you need to be looking at cost holistically in terms of not just what does it cost me to install the software, but what can I get out of it, all right? So what does it all mean? Well, Jason, I'll let you have some comments on what does it all mean.
Yeah, thank you. What does it all mean? What does it mean for customers, users, and application delivery? Well, it does seem that latency matters. Small differences mount up, and they do impact application performance. It's difficult, as Kevin said, to quantify that exactly, but for sure, higher latency leads to poor user experience and lower productivity and lost business as customers seek more convenient and better performing applications, which in the cloud era they usually find. Right. And the effects of latency, as I said, they're compounded for cloud native environments as we're starting to see customers notice the latency effects under load with some of the non-optimized open source proxies, and they're asking us, look, is there something better that we can do? And that's when we're introducing the CPX. But look, there are lots of examples where latency in general can cost business. Of course, the apocryphal statement by Amazon all those years ago that every 100 milliseconds of page load time costs them 1% in sales. And I know they spend a lot of time trying to bring that page load time down. Similarly, Google, they stated that an extra half second in search page generation drops their search traffic by 20%. Because they rely on advertising, that's probably 20% less revenue. So no wonder they spend millions trying to optimize their search pages, right? And there are examples of brokers losing millions in revenue for each millisecond of delay that they have over a competitor. And although that's probably not an ADC issue, it does highlight the importance of latency. But perhaps the most applicable impact statement I found was the report by Akamai that showed that a 2-second delay in web page load time increased the bounce rate of the customers by 100%. Wow. And that is a very real impact on business and something that would fall well within the scope of an ADC to fix. If you can, we talked about 5 milliseconds per object or 10 or whatever it is, and you've got a few hundred objects on there, that soon mounts up. And if you're going to lose half your people for every 2 seconds, then that's probably not a good way to run the business.
So we're talking about people impatience. Is that what we're saying? People are just impatient, and that 2 seconds is not going to go elsewhere and click someplace else?
Yeah, that's what they're going to do, Kevin. They're going to if it's taking a long time to load, they'll just go somewhere else. I mean, that's always been the way with the internet and the World Wide Web, but Akamai actually quantified it. That's not saying that it's precise, but in general, that's what it averages out as. But the other thing here, and you pointed this out earlier on here, it's performance really does count. If an ADC can deliver the same application with 50% less CPU, then in my mind that translates to smaller devices or at least fewer instances, which, as you also said, Kevin, in the hybrid multi-cloud environments leads to lower costs and less complexity. So it's a win-win. And similarly, the ability to handle that larger load means fewer, if any, auto-scale events, which are necessary to cope with fluctuations in demand. And if you've got this set up in a cloud, any event that's out of the ordinary can trigger a problem, and you want to minimize that as much as you can. Auto-scale is fantastic, but if you don't have to do it and scale up new resources and costs,
pay more money. Exactly.
Right? Yep. Exactly.
Yep. Yep. And I see.
Go ahead.
I see what you're saying. I see there's going to be a backlash coming where people are looking at their cloud costs and see how can we get these down. Do we really need to be having all those instances spun up all the time? What can we do to be more efficient?
Yeah, over-provisioning in the cloud over-provisioning's always been an issue, But over-provisioning in the clouds, you see that straight away with a higher bill, right?
Yes.
It's not a CapEx, it's an ongoing expense, and you're thinking, what can I do to bring that down? And to be fair, there are things that you can do, and I know Citrix with its pool capacity licensing and being able to shift things around and follow the sun, we've helped lots of customers reduce that load. But also, just using smaller and fewer devices really does help, in my opinion.
Yep, absolutely. Okay, then just to sum it up from our side, we have two reports. They're separate reports. They're both available free of charge. You can see a little picture of them there for you. The document numbers, and then our Tolly report library is right there. Every picture that I've shown you today, every graphic I've shown you is drawn from that report. So please get them and read them. Jason?
No, thank you very much. I would just add to this as a final thing that these reports are also available on the Citrix site.
Yep. Time for questions?
I think we have.
All right. Thank you, Kevin and Jason, for such an insightful presentation. Now, as we move into the Q&A, I would like to remind our audience that if you have a question, please submit it in the Ask a Question area on your screen. Simply just type your question into the text box and then hit Submit. Seems like we have a couple of questions on our queue, so I will start with the first one. Can we get more details on the WAF inspection that were carried out? You mentioned some of them, but is there a full list we can view?
Okay, thanks, Renee. Yeah, this is Kevin. Yes, we have them all listed in our report. So in addition to the ones I said, we've got protocol compliance, some different header settings, et cetera, evasion techniques enabled, but every single one of them that we had enabled for both products is listed in our report.
Yeah, I think that's important. I mean, the performance of ADCs with WAF enabled is so often overlooked. We all just assume it will work and there won't be an issue, but there is an impact. And we're seeing so many customers, as I said before, consolidating their WAF into the app delivery controllers now. So it's really, I think, only fair to show them what they can expect, hence the test that we asked you to do. Next question.
Absolutely. Thank you, Jason and Kevin. So we have another one in queue. In the ADC test, you mentioned that C5 and 4 by large instances were used. How many CPUs was that?
Sure. The C5N has 8 CPUs or 16 vCPUs with hyperthreading for both devices. And again, we have this information in more detail in our report. The hyperthreading was disabled. It doesn't add any value in the networking loads, and both F5 and Citrix recommend disabling it, so it was disabled. And again, details at that level you can find very easily in our report. Thanks.
Sure, but just on that, so we use the C5N for the core ADC test, but we had to use the C5 4x large. And the N is really designed for networking. That's what the N means in these instances, and the other one isn't.
Mm-hmm. Yep, good point.
All righty, I'm wrapping this up. We have two more in queue. The next one is, in what type of cloud-native architecture are the tests versus Envoy relevant to?
Okay, I think we may have covered this one already in looking at the application-to-application service mesh. But Jason, any further comments on that, or you think we covered that?
Well, we did, but I'll just remind you, look, the service mesh, Envoy is very popular in the service mesh. It acts as a sidecar to the pods. And of course, you say all of the traffic will go through the proxy then, like Envoy or CPX. CPX will drop in and just replace Envoy across the board as a straight swap. And it can be controlled by an Istio control plane or other control plane, and it then delivers a lot less latency in the data plane. And as an aside to that, Citrix also recommends a service mesh light architecture, where the individual sidecars are sort of brought together into a centralized proxy. And here, CPX can work within the cluster and be that centralized proxy. And we're starting to see customers looking at that more because they want the benefits of service mesh, but they don't necessarily want the overhead and complexity that comes with it. So they're starting to get more people interested in that architecture.
Good stuff.
That is great stuff, Jason. Thanks for going more in depth and clarifying the asked question. So we have one more and last question, and that is, why didn't you stay with the C5 and 4 by large for the WAF test?
Okay, sure. So there just was no version of the F5 software that supported the C5N and the WAP, so we shifted to the C5 4X large. So we did it for both devices, so it's a fair test, not a major change, and as I know, it's the same for both, so it's apples to apples. Thanks.
Alrighty, well, thank you very much. That brings us to the end of our presentation. I would like to thank Kevin and Jason for a very informative and insightful presentation, and also thank our audience for joining us. A quick reminder, you can check out and register for upcoming webinars and events by going to citrix.com/events. We hope you have a wonderful day.